All right, so today we're going to look at chapter 4. Chapter 4, the first part is about the free body diagram. So our main focus today would be a free body diagram and including how to form equation based on free body diagram. I've gone through your solutions and then I found that quite a lot of you got a correct answer, which is good. But then still got a few of you who got the wrong answer. Okay, so I've already taken a few examples here. We'll go through them. Okay, so don't copy the answers given in the PowerPoint yet. Okay, because the examples that I've chosen is the wrong one, and I will tell you where is it, where is the mistake, and how to correct it. So how to sketch free body diagram. So these are diagrams on the right hand side. Basically, it sums up the 4 steps that you need to know in a sketching free body diagram. First, you use a dot, okay, to represent the object. So basically, you don't draw the floor, okay, you just use a dot. So use a dot to represent the object. And then, okay, you place a coordinate system. So usually, I won't draw a x and y axis. I will just use 2 vertical lines. So a 2 dotted vertical line. And then step number 3, you represent force as a vector. So let the force comes out from the object. And then step number 4, you resolve it. So let us start from questions 1. Now, questions 1, if you notice, the notes tells you the object is moving with 0 velocity. Okay, it is not moving. It is at rest. So if it's at rest, then the v is equal to 0. All right. So why is it important to know that the v is equal to 0? I will tell you when we try to form the equations. But right now you have an object that is not moving. So how to sketch the free body diagram for this object? Now, basically, all of you got it wrong. Just that make sure you draw a dot slightly bigger. Okay, because this dot represent object. Some of you, you just give me 2 lines without a dot. So that is not a very good idea. So you draw a dot. Now, since this is a very simple question, I don't have to draw a dotted horizontal and a dotted vertical line. Straight away, I can draw the forces acting on the object. So remember, you're looking at the forces acting on the object. So first, if you look at this object A. Object A, now try to ask yourself 5 questions again. Is this an object? Yes, it is. So if it is an object, what does it have? It has a weight. So is it being hung by any strings or wires? So no means there's no tension. Now it's not moving, definitely no frictions. And then what else do we have? Okay, we have now is it touching the surface? Yes, it is. Therefore, we have a normal force. Okay, so this is a normal force. And then is we don't have any external force acting on the object, therefore no external force. So out of that 5 forces, we have only normal and also weight. And the next step, we are going to form an equations. So how to form an equations? You look at the keywords given. The question tells you object is now at rest. If object is at rest, then we are going to apply Newton's first law. So summations F equals to 0. If you look at this diagram, so we have n minus w equals to 0. Therefore, n is equals to w. So questions 1 is very simple. Basically, all of you got it correct. All right, so summations F, I would prefer to put a y here to show that this is a vertical force. So questions 1, no problems. Now questions 2. Let's look at your friend's answer first. So I tried to just get one wrong answer from one student. All right, so your answer will come out at most once only in our lesson today. So first of all, what is the mistake in the first diagram? If you look at the questions, okay, now you have a force pushing an object B. Therefore, now you have a force that is going towards this direction, which is correct. The second one, this is an object. So object come with weight, which is good. And then what else do we have? Now it is touching a surface, a vertical surface. Therefore, normal force is going to the left, which is good. But one thing is missing. If you look at the questions mentions what? So questions mentions rough surface. So now you have rough surface, means that it should have a frictional force. Okay, it should have a frictional force. So what is the directions of frictional force? Now you try to imagine if you push something, okay, an external force is being acted on the object. So you push object B, but it is not moving. Why is it not moving? Because there is a frictional force stop it from moving. Okay, so if the frictional force stops the object from moving after it is being pushed by this external force, what does it mean? It means your frictional force is going downwards. Okay, so this is your F. Fk. Okay, Fa should be Fs. It's not moving. Okay, but you can just write F here. Okay, F or Fs because it's not moving. So questions 2 is still an object without moving. So one force is missing. In exam, in this case, 1 mark will be deducted. Okay, 1 mark will be deducted. Now let's look at the second diagram. Why is it wrong? Okay, first you got the N, which is correct. You got W, which is correct. You got F. Well, subscript wrong. I can just close my eyes and pretend I'm not seeing it. But then, okay, in your free body diagram, if question asks you to sketch free body diagram, you shouldn't resolve it straight away. You should put the original force. So original force is F, that is heading towards northeast. All right, so Fx and Fy. Okay, if you want to put it in your diagram, okay, you use a different color pencils. Okay, so you use pen for the diagram and then you use pencil for Fx or Fy. All right, you cannot just put these two force straight away. In this case, questions will assume it's wrong because you're assuming there are two external force Fx, external force Fy. But according to the questions, you have only one external force and it is pointing towards northeast. It is pointing towards northeast. So in this case, you have this wrong, and then this one is also considered as wrong. Okay, all right, you cannot resolve it yet if the question asks you to sketch free body diagram. But if the question just asks you to calculate resultant force, then yes, you can leave it like this. So that is a difference between a question that asks you to sketch free body diagram and also a calculations questions. For calculations questions, the diagram just now is perfectly fine, right? But in a free body diagram questions, then you should plot everything nicely. So the correct diagram should be, okay, this is the object, then this is the external force, and then you have a weight going down, and then frictional force overlapping with weight. Okay, you don't draw a line that is beside it. It should be overlapping. And then a normal force. Okay, a normal force going to the left. So this is a free body diagram. Right? So if you want to draw XY plane, usually I will use a dotted line to represent XY plane. And then if you want to put Fx and Fy, then you use a pencil. So after you sketch this diagram with pen, then you use pencil. Okay, Fx, Fy. So pencil, why is it importance to use the pencils rather than pen? Because pencils means that you are telling the examiner don't mark it. All right, because in your official exam, if you use pencil, examiner have right, don't want to mark your paper. Okay, they can assume it's wrong if you write everything with pencil. Because it's written there, you must answer it with pen. So if you use pencil in your diagram, you draw everything with pen, but then Fx and Fy you use pencil, means that you're telling examiner just ignore it. Okay, you're plotting it for the sake of a calculation. Okay, now how are we going to solve it then? Since these are questions 2, again, object is at rest. So object is at rest, summations Fx is equals to 0. Okay, first law again, because object is not moving, object is at rest. So you look at x component. So where is the x component? This is our x component. So x component, okay, now you can resolve it because you need Fx in your equations. So in this case, Fx is going to the left and then the n is going to the right. So Fx minus n equals to 0. And at last, we know that Fx equals to 0. And then for Fy, summations Fy for y components, summations Fy is equals to 0. And then what can we do about it? So we can resolve it. Okay, we can also resolve it. So now we are looking at the vertical component. So Fy is going up, and then a minus F minus W equals to 0. Therefore, we can also say Fy equals to F plus W. Okay, now assuming the angle is beside x component, what can you do next? So if you look at these two equations, Fx and Fy. So Fx and Fy, you need to resolve it. And assuming angle is beside x component, oh, just now I make a mistake. It shouldn't be equals to 0. It should be equals to n. So if angle is beside x component, what should you do? You can then resolve f into x component. So f cos theta equals to n. So for vertical component, f sine theta equals to f plus w. So this is how you resolve it if it involves a 2D, okay, two-dimensional. So fx, okay, you have two forces after you resolve this f. So you have fx and fy. So fx, you need to resolve it. It becomes f cos theta, and then fy becomes f sine theta. That is how you resolve it. All right, so make sure you know how to sketch a correct and complete free body diagram. Right, correct and complete free body diagram. So let's look at the next question. So next questions number 3. So questions number 3, how are we going to do it? Okay, so first you have object C. Now object C by nature, okay, it should drops, okay, and then it would drops. By nature, it should go down, okay, it should slides down. Therefore, in this case, we have frictional force that's going up. But remember, what did I tell you in the previous class? Frictional force, the symbol is a small letter f. All right, frictional force, the symbol is a small letter f. In your free body diagram, you must use a correct symbol. If the symbol is wrong, then it will be considered as wrong. Okay, it can be considered as wrong. So this one, you have a frictional force that's going up, so small letter f, which is correct. And then normal force, which is perpendicular to the surface, so also correct. And then W, which is going down, okay, which is also correct. So the first mistake here is the friction. Friction, you use the wrong symbol. All right, you don't write down the full names, you have to use a symbol. The second thing that is wrong is what? Now, if you look at the diagram, you are given the angle. If you are given angles, then you need to put it in your diagram. So where should you put this angle? Now, let's assume, okay, let me extrapolate this line, make it longer. So if you look at this line, it tells you that W is actually perpendicular to the horizontal line here. So which means this is actually a triangle. Okay, a triangle here. And then we have x and y component. So this is our x component. This is our y component. All right. So which means these angles, the angles given, the angles of this slope surface is actually the angle beside y component. Okay, the angle beside y component. Why? Because the angles inside the triangle, which is this angle, all right, this angle is 90 minus theta. Right, and then in between x and y component, it forms 90 degrees. Therefore, the angles beside y component is the theta. Okay, so in your diagram, you should add a vertical line here and shows that the theta is here. Right, because you are given theta in the diagram, therefore you need to have the angles in your free body diagram. So 2 mistake in this graph, therefore you got 0 marks. Okay, you got 0 marks here, right? Minus 2, because you got 2 mistakes. One, wrong label. The second one, wrong angles. Okay, you didn't label the angle. Okay, then how about next one? Okay, next one, I crop it out. I put it here because in a free body diagram, if your questions, okay, sometimes questions, they will split it. Questions A asks you to sketch free body diagram. Questions 2 ask you to do a calculation. This diagram is a typical diagram for calculations. When it comes to free body diagram, it will be better to follow the diagrams given. Okay, to sketch the force according to the diagram given. So a better way to answer a sketching question is, now this is your object C. So frictional force is going up, and then a normal is here. Okay, the angle between them is 90 degrees, and then you have a W going down. So this is your angle. So this is a complete marks. It's a full marks answer for a sketching question. So you follow the diagram given. You don't rotate it yet. Okay, you only rotate the x and y component in a calculations questions. So initially, what are you doing? You are assuming this is your x component, this is your y component without rotating it. Okay, without rotating it, you keep it at its own diagram, okay, original diagram. So in calculations, you can then rotate it, okay, and obtain this diagram, all right, and obtain this diagram. But still, the mistake here is a symbol again. Okay, you look at the symbol. Now you are resolving the vector for first. How can you write it as fx and fy? It should be wx and also wy. So if you use wrong symbol in your calculations, if you got everything correct, then that is fine. But in case you make any mistake in your calculation, and we go back to your formula, your step, you wrote it down as fx and fy, then it will be considered as wrong. Okay, because you are not calculating weight, you are calculating external force. Okay, you're calculating external force but not weight. So you have to be extra careful with this symbol in chapter 4, because every force, it comes with its own symbol. Make sure you use a correct symbol. All right, so it should be wx, wy in your calculations. You shouldn't put fx, you shouldn't put fy. Okay, and then don't rotate the plane, the xy plane yet in the sketching questions. Sketching questions, we always follow the diagram given without rotating it. We only rotate it in the calculations questions. So now let us from equations. So summations f. Now question 3 still v is equals to 0 because object is at rest. So whenever object is at rest, we apply Newton's first law. So summations fx equals to 0. So along x component, what do we have? So now you can resolve it. Okay, you can resolve it. So this is your wx, and then this is your wy. Okay, wx and wy. So what am I going to do now? So let's look at the x component. X component, I have f minus wx equals to 0. So wx, obviously you have to resolve it, but if you look at the diagram now, angle is beside y component. Therefore, f minus w sine theta equals to 0. Okay, or to make it easier, let's write it as f is equals to w sine theta. So right hand side equals to left hand side. And then for y components, summations fy equals to 0. So y components, again, so we have two forces, and minus wy equals to 0. So n is equals to w. Now because the angle is beside y component, therefore cos theta. Okay, cos theta. So n equals to w cos theta. So that is the correct answer for object number 3. Object C. Okay, object C. So that is how you solve it. So be extra careful with the free body diagram, all right? So all this free body diagram, if you do it in the exam, you won't get full marks because of various mistake. All right, and next questions. Questions number 4. Okay, questions number 4. Some of you gave me this answer. Now, you know there is a tension, but is this the directions of tension? Obviously, it is not. Okay, so WD, yes, WD is going downwards, but now tension is not just going up. If you look at the diagram, you look at the directions of the string. Okay, now you have a 1 string, you have 2 string. So what are you going to do? You are going to draw them as 2 different T. So let's call it T1, let's call this T2. So object D is a dot. Every object comes with a weight. So I have a WD going downwards. And then T1 going to the right and T2 going towards this direction. So since the angle is not given, so I can skip the angles. I don't have to include angle in my free body diagram. So is it touching any surface? No, it is not. Right? And then does it have any frictional force? Obviously no, because it's not in contact with any surface. Now, okay, how do I know, okay, whether I want to use T1, T2, or I just use T for both of them? You look at string. If this T is coming from same strings or same wires, it means that both objects, they are going to have the same tension. But now you have two different strings, which means these two tension, they might have different value. Therefore, you cannot just simply label it as T. Okay, it must come with a subscript, T1, T2, to indicate that these two tensions, they might have different value. Okay, they could have same value, but they might have different value as well. Because it is unknown, therefore we label it as T1 and T2 to tell the examiner that you know there might be two different tension in this diagram. So now that I have this complete diagram, what am I going to do next? So I want to resolve it. So this is my x plane, this is my y plane. So summations fx, again, questions D is object is at rest, object is not moving. So summations fx equals 0. So summations fx is equals to 0. Let's look at my diagram. My diagram, I have T1, and then what else? I have T2 at an angle. So let's assume angle is beside x component. So T1 is going to the right, T2x is going to the left. Therefore, I have T1 minus T2x equals to 0. So T1 equals to T2 cos beta. Okay, so this question, I'm just assuming my angle is beside x-axis. In an actual questions, the angle could be at y-axis. So make sure you read the questions carefully. And then for the y components, summations fy equals to 0. So along the y component, what do I have? Now, if you resolve T2, then you have a T2y here. Okay, you resolve T2, you have a T2x here. Therefore, summations fx equals to 0. T2y minus w equals to 0. So I have T2 sine theta equals to 0. Right? So that is how you solve equations. You sketch a free body diagram first, even though the question didn't ask you to sketch it. Okay, you need to sketch the free body diagram. Make it a habit. Okay, make sure every question has a free body diagram. All right, so next, I'm going to look at the questions 5. So while I explain, you mark your own answer, okay? Because got quite some of you got a wrong answer here. Okay, got quite a few of you got a wrong answer. All right, now questions 5. Questions 5, let's see. Why is it wrong? If you look at this diagram, now you have two objects. Therefore, you draw two free body diagram, which is very good. Okay, so one for object E, and then one for object F. Make sure you label it. Okay, in exam, make sure you label which free body diagram is for which object. Okay, now the reasons why I say your answer is wrong, it is because of the tension. Okay, this tension and this tension. T2 and T3, they are coming from the same string. So you have T1 here. Now this is your second T. Okay, this is your second T. Both of them, they are coming from same string. Therefore, you should call it T2. So this is wrong. All right. So because the strings that is joining E and F together, okay, is coming from the same string. Therefore, this one, it should be labeled as T2. All right. So the first one is T1, which is correct because it's coming from a different string. So object E come with a weight, which is correct. And then it is being connected by another string. So you have a T2 going downwards, which is very good. Okay. So for object F, you have T2 going up. So I know it's T2 because it's joining together with an E and they both have the same string. Okay. They both are lying on this, coming from the same string. So object F again is a weight. Okay, object F is an object, so it has a W. All right, so basically this free body diagram is correct, just that the label is wrong.
Madam,
Yes.
Kalau saya punya WE kat bawah tak apa ke?
WE dengan T2 punya tempat terbalik.
Terbalik.
Tak ada masalah. Sebab sebelum kamu kira, memang kamu tak tahu yang mana satu nilai dia lebih besar. Okay, but once you have the value, then you have to be careful with the length. The one with a larger magnitude should have a longer length. Okay, so next. Now let's look at the equations. So again, questions 5 is happening when the object is at rest. The object is not moving. Therefore, summations fx is equals to 0. And fx, now I don't have x component, I can skip fx. Straight away, I go to fy. Okay, straight away I go to fy. So this is for object E. So when you form equation, make sure you label clearly this equation is for which object. So usually I like to write a title here. Okay, object E before I start for doing any equations. So object E summations f is equals to 0. So according to the diagram, I have T1 minus WE minus T2 equals to 0. Therefore, T1 equals to WE plus T2, right? And then for object F, so again, object F, we only have a y component. So summations Fy is equals to 0. So now what do I have? I have T2 minus WF equals to 0. And T2 is equals to WF. Now, usually, if you are given two objects, you can form at least two equations. And next step is you need to think how to join these two equations together. And apparently, the same terms, okay, the terms in the equations, object E and object Y, they both have one same variable, which is your T2. So T2 is the terms that you can use to do a simultaneous equation. Okay, oops. So what do I have here? Now I have equations 1, and then I have equations 2. So if you need to combine these two equations together, if you need to join these two equations together, then what can you do? You sub 2 into 1. Okay, you substitute equations number 2 into equations number 1. Then you can link these two equations together. All right, you can join these two equations together. So sometimes questions won't give you T1 and T2. It asks you to determine T1 and T2. So what you can do, you determine T2 by using object F. And then from object F, you know that T2 is equals to WF. So substitute T2 into equations 1. All right, so WE plus WF is equals to T1. So from here, you can then solve the questions and get the answer for both tensions 1 and tensions 2. So that is a technique in solving questions. You need two equations. So you try to reduce the variables. Okay, we try to use same variable. That's why I told you both of them, they should be T2. You don't use one T2 and one T3. All right, because if you are creating more variables, then it will be hard for you to solve the simultaneous equation. Okay, so this is questions number 5, questions with the two objects. So questions number 6. Okay, questions number 6. Now, questions number 6, object is moving with constant velocity. Okay, so constant velocity, again, what do we know based on these keywords? If an object is moving with constant velocity, means you're going to apply first law as well. Okay, so at rest and first law, we at rest and a constant v, we apply first law. Okay, at rest and constant v, we apply first law. So this is the keywords that you need to look for in the questions. Now, how to solve these questions? Let's start from a free body diagram. So this object, okay, is being pulled by a tension, by a string. Therefore, you have a tension, which is correct. And then the second thing, now you have a normal force, okay, which is perpendicular to the surface. So you have a tension, you have a normal force. So normal force is correct, 90 degrees in between them. And then you have a weight that is going down. So angle is beside y component. Now, in a sketching, even though you don't have to follow the exact scale, but at least make sure it don't sengit like this. Okay, your idea I can see is correct, but your W sengit too much. It should be pointing downwards, but now this one is already like pointing towards southwest. Okay, pointing towards southwest. So it should be straight line going down like this. Okay, it should be a straight line going down like this. So even though it is sketching, don't let the diagram off too much. Alright, jangan bagi dia sengit terlalu banyak. So W ini dah obviously sangat sengit. It's no longer pointing downwards. So in that case, it is considered as wrong. 1 mark will be deducted. Alright, so make sure it's a straight line that is going downwards. So angle is here. This is your angle. Okay, so angle is fine. Only the directions of W is wrong. Okay, only the directions of W is wrong. So how are we going to solve these questions? Again, same as the previous questions. Okay, same as the questions that we discussed just now. So let me redraw a diagram. So this is my X component. This is my Y component. So I use dotted line. Okay, I use dotted line to represent X and Y component. Make sure you don't put arrow. Okay, make sure you don't put arrow along the X and Y component because sometimes it might be mistaken as one force. Alright, kalau kamu guna solid line dengan arrow, dia akan dianggap sebagai satu force. So to be safe, you use dotted line. Okay, dotted line to represent X and Y component. So you have a T that is going towards this direction along X component, and is along Y component, and then W that is going straight down. So this is the angle. All right, this is the angle. And then you can resolve it with pencil. So this is my WX, and then this is my WY. All right, next, I can form the equations right now. Now, when it comes to these types of questions, okay, an object that is moving, usually I like to draw the directions in my diagram. Because the directions of motions, I will take it as a positive direction. Okay, so my V now is going up. So I draw it outside free body diagram. Okay, as you can see here, don't let it start from origin. Okay, some students, they like to put it here, which is wrong. Okay, which is wrong. If you put it in your free body diagram, then it will be treated as another force. Okay, so 1 mark will be deducted because you add an additional force into your free body diagram. So direction, you put it outside free body diagram, like what I did here. So now I want to resolve it. I want to solve it. I form an equation. Summations Fx equals to, okay, constant velocity. So 0. And then what do I have? T minus Wx equals to 0. So T is equals to W. Now, because my angle is beside y-axis, therefore for x component, I use sine theta. So this is my first equations. And then second equations, I have summations Fy equals to 0. Okay, so along y components, again, what do I have? I have n minus Wy equals to 0. Therefore, n is equals to W cos theta. So second equations. So you see, usually when we form 2 or more equations, there must be a same variable. Okay, they must have the same variable so that you can join these 2 equations together. Okay, you can combine both of them together. All right, so you now have equations 1 and equations 2, then you can solve it, right? So because you have a sine theta here and cos theta here, you remember a relationship, a very important relationship, which is a tangent theta is equals to sine theta over cos theta. All right, this relationship is very important when it comes to simultaneous equation. So make sure you remember it. Okay, make sure you remember it. So this is questions number 6. So questions number 7. Okay, questions number 7. Now your object is moving with constant acceleration. So let's look at the diagram. Okay, let's look at the diagram for object G. Now, how am I going to sketch a diagram? You need to remember, when it comes to free body diagram, you want to sketch the force exerted on the object. Okay, let's look at object G first. Object G, you have a normal force going up, which is correct because you put it on top of a surface. And then you have a WG because it's an object. Every object comes with weight. Now, how about force? Now you are pushing the object with an external force F. So you should label it as F, but not FG. Okay, so this is wrong. This one should be F. Okay, this one should be F. And now, if you look at the diagram, 2 objects, they are in contact with each other. So what does it mean? It means when you push object G will push object H. But according to Newton's third law, okay, let's say your object G is pushing object H with a force Fg. So Fg is actually a force exerted on object H. Okay, it is a force generated by object G and it is being acted on object H. So this FG should be drawn in a free body diagram for object H, but not object G. So according to Newton's third law, if object G pushing object H with a force of Fg, that means at the same time, object H will push it back with the same amount of force, but in the opposite direction. Okay, just like the examples that I told you in a lecture, this is a vertical wall, this is you. Now you are pushing the wall. Okay, you are pushing a wall. So when you push the wall with 10 Newton of force, okay, this wall actually is pushing you back with a 10 Newton of force, but in the opposite direction. So this is what happened at the place that the two objects in contact with each other, touching each other. So object G is pushing object H with a force G, and object H is pushing back with the same amount of force, but in the opposite direction. Therefore, what we know here is Fg is equals to negative Fh. Okay, so in your free body diagram, what should you do? Now, other than F, which is the external force acting on object G, actually at the same time is being pushed back by an Fh. Okay, so object G, it should have 4 forces acting on it. Okay, 4 force yang acting pada object G. So first is external force, because external force is directly in contact with object G. So I have F, and then when object G pushing object H, it is being pushed back by object H at the same amount of force. Therefore, I have Fh going backwards. Okay, and then I have an Ng going up, and then Wg going down. Okay, Wg going down. Now let's look at object H. Object H, okay, this label should be Fg. Okay, because it is a force generated by object G. So object G is pushing this object with the amount of force known as Fg, equals to Fg. So now you have a Fg going to the right. Now, don't include this external force. All right, so in your example, which is very good, you didn't include this external force, because this external force is not being acted on object H. It's being acted on object G. The force that is directly in contact with object H is your Fg. Alright, kita cari force yang terus kena pada objek. Kalau ada objek di tengah-tengah, force dengan objek kedua, then kita tak anggap force ini sebagai force yang kena pada objek H. Okay, because you have an object G in between external force and H. So external force is not being acted directly on object H. Alright, so the second diagram just got a minor mistake. So object H, you got a force coming from object G, so I called it Fg. And then you have NH, and you have also WH. So this is a free body diagram for object H. So now you have a smooth surface, so good, you don't have frictional force. So let us form a free body diagram, form equations. Okay, now if you look at the questions, now object with moving with a constant acceleration. So my object is moving with constant A to the right hand side. So what does it mean? It means I am going to use right hand side as a positive direction, left hand side as a negative direction. Okay, we take directions of object of the motion as a positive direction, and then the other side, the end of the arrow, the tail of the arrow as a negative direction. So let's form a equation for object G. Object G, now if you look at the diagram, object is moving with constant accelerations along x component. In that case, it means x component summations fx is equals to ma. Okay, it applies Newton's second law. Why? Because now object is moving with constant acceleration, constant a. So once you have these equations, okay, you can just write down ma here. Then you expand the equations on the left-hand side. So since I take right-hand side as positive direction, so I have F minus FH equals to MA. Okay, equals to MA. And in this case, my M should come with a subscript. So what am I going to do? I want to add the subscript for my M, because now you are looking at object G. So MGA. Okay, MGA. So A don't have subscript. Why? Because now these both objects, they are moving with the same acceleration. Therefore, you don't need to put subscript. And then the Y component, summations Fy. Now, since there's no motions along Y component, object just move with constant accelerations along X component. All right, therefore, for Y component, we use first law. So summations Fy equals to 0. Therefore, we have Ng equals to Wg. Right? So you have two equations from first diagram. Okay, two equations from an object G. Okay, from object G. Now let's look at object H. So object H, again, you look at the diagram. Now my acceleration is moving along, is lying along the X component. Therefore, summations Fx is equals to MHA. Okay, because now I'm looking at object H. So summations Fx, now if you look at these questions, what can you say about it? Now you only have one force along X component, in which it means Fg is equals to MHA. Okay, Fg is equals to MHA. So this is for the X component. And for Y component, summations Fy, again, there's no motions along Y component. Your object doesn't move up and down. Therefore, summations Fy is equals to 0 and H is equals to WH. So again, another two equations from object H. Okay, another two equations from object H. So you can have four equations from this diagram. All right, you can have four equations from this diagram. So object G, object H. Now sometimes questions will ask you to assume both of them as one object. Okay, to combine this both G and H as one object. And in that case, what is going to happen? So in that case, you will have only one free body diagram. Okay, where this free body diagram, it has a weight, which is W, and then the weight will be the total weight of both of them, G plus H. Because now you are treating these two objects, okay, you are treating the two of them as one. Okay, you are treating it as one object. So this one object, now the total mass is G plus H. The total weight is G plus H. So now you treat it as one object, therefore you use WG plus H. And then what do you have here? You have NG plus H as well. Okay, this is if you treat it as a one object, right? So in this case, what is the force that we have along the X component? We don't have Fg and Fh anymore. What do we have? We have just external force F. Okay, and then in this case, my A is still going to the right. So in this case, what am I going to do? Now I can form an equations for X component, summations Fx equals to M. But now because I'm treating G and H as one object, therefore Mg plus H. A. Okay, and then expand the equation is just F equals to Mg plus H A. So this is the third possibility. Okay, possibility ketiga. And then summations Fy again is equals to 0. What do I have? I have N G plus H equals to W G plus H. So another two equation. So basically, based on this diagram itself, I can have a 6 equation. All right, I can have 6 equations. So depends on how are you going to apply it in order to solve the question. And this is a very important relationship when it comes to the first 4 equations just now. Okay, so bila dia ada dua objek yang sambung begini, kadang-kala Anda kena anggap dia sebagai satu objek baru boleh jawab soalan. So bila kamu anggap dia sebagai objek, kamu kena kira total weight dia, kamu kira total normal force dia, kamu kira total mass dia. Alright, so that is how you solve it. So there are 3 possibility, 3 diagram, free body diagram that can be drawn for just this question 7. All right, so this question is quite important. So I let you write it down because most of you didn't put this third diagram. Diagram number 3, okay? You don't have the third diagram. So now I give you 2 minutes to write it down, okay? 2 minutes untuk kamu salin dia. Okay, so 2 minutes untuk kamu salin, especially diagram ketiga. Ramai yang tak ada. Alright, 2 minit bagi anda catat. So if you guys have any questions, make sure to ask, yeah? If you don't ask, then I don't know whether you understand or not. Okay, pastikan anda faham soalan ini ya, sebab ini pernah keluar sebagai soalan past year. Okay, soalan ini dia pernah keluar sebagai soalan past year. So make sure you understand how to solve it, the idea in solving these questions. So ramai orang tak boleh jawab soalan ini sebab dia tak tahu buat equations ketiga ini, diagram ketiga ini. So you can have 3 different diagram. Alright, next. So questions number 8. So questions number 8, this questions obviously is incomplete. Now you have 2 objects. When you're given 2 objects, means that you need to have 2 free body diagram. And you didn't even label this diagram is for which object. So in exam, it will be considered as wrong. Okay, so this will be considered as wrong. Why? Basically because you didn't tell the examiner this diagram belongs to which object, and also there's no subscript. Okay, if you put subscript, at least you put J here, then at least I know this diagram is correct because of the J. Okay, because you got J and this force is directly being acted on J. Okay, not on all the other forces. So how am I going to draw a diagram for this then? Okay, let's begin with object I. So object I, okay, I is being pulled by a string, therefore it has a tension. I is an object. Every object comes with weight. So Wi, sorry. And then I is being placed on a surface. It's in contact, in touch with another object, another surface. So it has a normal force. And I again. And then it's being placed on a rough surface. So I'm going to use F, but now you need to label Fi. Why Fi? Because if you recall the equation for frictional force, F is equals to mu n, which means it depends on n. Since object I comes with ni, therefore the frictional force for I and j, they are different. So you need to put a subscript there to indicate that you understand. The F, they have same value for object I and object j. So object j, I'm going to draw it here. So object j. So object j, what do I have? This is the object. Now you have this external force is being acted on the object directly. So this external force, F. There is a string behind it. And this is the strings that are joining I and j together. It means both of them, they are using the same string. Therefore, this is a T. Okay, this is a T here. Object j is an object. Again, every object comes with a mass. So a W, J, and then you have N that is going up, and J. Now again, it is being placed on the rough surface, therefore I have Fj. So basically object J, it has 5 forces. Okay, it has 5 forces. So you make sure you have all of them correct. Okay, make sure you have all of them correct. So next, what am I going to do? I'm going to form equations as usual. So again, you need to know what is the directions of A. Okay, so again, this question is being very nice to you. It gives you A going to the right hand side. So this is a positive direction. This is a negative direction. So object J, say A is going to the right, means that this is a positive direction. This is a negative direction. So what am I going to do now? I'm going to form equations for X component and Y component. Again, object I. Object I, summations F X equals to M A. So M I A. Okay, this A is happening along X component. Therefore, for X components, we apply second law. So in this case, because I'm taking right hand side as a positive direction, so T minus Fi equals to MIA. So this is the first equation coming from object I. So for a Y component, because there's no motions along Y component, so summations F equals to 0. So make sure you know when to use first law, when to use second law. So first law, I have Fy equals to 0. So Ni minus Wi equals to 0. And I equals to Wi. Okay, and I is equals to Wi. So for object J, then what should I do? So object J, again, I'm going to repeat the same thing. So basically, you just keep repeating the same thing. The most important thing is you get a correct free body diagram. So summations Fx equals to MJA. Okay, so along X component, I have a 1 force going to the right and 2 forces going to the left. So external force minus tension minus Fj equals to MJA. So first equation, Y components, summations Fy equals to 0. And then I have a Nj equals to Wj. Okay, Nj equals to Wj. So that is how you solve it. Okay, that is how you sketch a free body diagram, and that is how you solve it. All right, so this is questions number 8. Okay, I'll give you 1 minute to write it down. Then we'll look at questions 10 and questions 11. Questions 12, I will keep it for tomorrow. Okay, questions 12, I'll keep it tomorrow. We can discuss together with the other class because they stop at questions 11 as well. Okay, so 2 more questions. So 1 minute for you to write it down. All right, next one. So this one, okay, this question is interesting. Why? Because now you have A in 2 different directions. L, the A is going to the right, but for object M, the A is going downwards. So this is the things that you have to take notes. So this question, surprisingly, all of you got the correct answer. I don't know whether you do it by yourself or you refer to the video from other class, okay? But make sure you need to understand how to solve this question. So now you have object L. Okay, object L. Object L is being connected by a string, so you have a tension. Okay, this is object L. So tension's going to the right. Now you place it on the rough surface, so it has a frictional force. So this question, I can just write F because only one object experiences frictional force. So object L is a object, like I said, every object comes with weight. So WL. And now you place it on a surface. So it has a normal force, NL. So this is a free body diagram for object L. And then A is going to the right-hand side. And then object M. Okay, object M. So object M, now I have an object come with weight. So WM. It's being hung by a string, therefore I have tension. And again, if you look at the questions, now because they are being connected by the same string, okay, therefore I just use T without subscript. And this is the variable that can be used to combine two equations together, okay, two objects together, which is a T. And now I have an A going downwards. So which means for object M, I'm going to take downwards as a positive direction and upwards as a negative direction. All right, what does it mean? We'll find out soon. Now let's go back to object L. Object L, as usual, I'm going to form equation for X component. And now because my object is moving along X component, so my object L as summations Fx is equals to MLA. Okay, MLA. So according to the diagram, right-hand side is positive, so T minus F equals to MLA. So this is first equation. Second equation is coming from the Y component. So summations Fy equals to 0. So what do I have? I have a NL equals to WL. So second equation. These second equations, usually we use it to find a frictional force. Okay, remember F is equals to mu N. So usually frictional force won't be given. You need to obtain N from equations 2 to calculate frictions in order to be used in equations 1. Now let's move to object M. Object M, we have only Y component. So summations Fy equals to MA. But now if you look at the diagram, downwards is a positive direction. Okay, downwards is a positive direction. So what am I going to do? I'm going to use W as a positive vector. So WM minus T is equals to MMA. Okay, now you see I take downwards as a positive vector and upwards as a negative vector now. So this is the third equations. So why do we need to form that much equations? Okay, because sometimes you need to use simultaneous equations to solve it, especially for equations 1 and equations 3. So equations 1 and equations 3, you can solve it by using simultaneous equations because they have same T and they have same A. So two unknowns with two equations, okay, therefore you can solve it by using simultaneous equation. Biasanya, bila ada soalan begini, dia akan minta kamu determine T and determine A. So this is what you should do. You need equations 1 and equations 3. And in case you are not given the values of frictional force, then you need equations 2. Okay, equations 2 usually is for frictional force. It's for you to use in determining the frictional force. All right. So this is questions 9. Okay, this is questions 9. Now, sometimes for object M, when you look at reference book, they will write it as summations Fy equals to negative MNA. Okay, this is when they take direction upwards as positive direction. Okay, but because you need to modify the equations into a negative equation, that's why I don't encourage my students to use it. If you use negative MA, then you're still going to get T minus WM equals to negative MMA. But this will make the whole calculations becomes complicated because you always have to think when to use positive NA, when to use negative MA. That's why I don't encourage my students to use these equations. Okay, I prefer you to use directions A as a positive direction. Okay, so A here, we are going to take it as a positive direction. All right, we take A as a positive direction. Then the vector that is pointing towards directions of A is a positive vector. In that case, it will be easier for you to form any equations, for you to solve all of the equations. You don't have to think when to use summations F equals to MA, when to use summations F equals to negative MA. Right? So now it's 11. Group A, you guys can leave first. Okay, I want to finish one more questions with a group B. Then questions 12 until 14, we'll discuss it tomorrow. Okay, questions 11 until 11, 10, yeah. The other 3 questions I'll discuss it tomorrow. So group A, if you have a class, you may leave now. Group A or group B? Terlupa. Mana-mana. Okay, so question.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay, so let's look at the last questions. So questions 10. Questions 10 is very similar to the previous questions. Okay, why? Because now you have 2 objects, but 2 of them, they are moving towards different direction. One going up means the other one must be going down. All right, so this one, actually, all of you got the correct answer as well. That's why group A can leave early. Okay, no issues because you know how to solve it already. So object P, let's do a free body diagram for object P. So object P, okay, what do we have? We have an object P. Now object P is an object. Every object comes with weight. So we have WP. Object P is being hung by a string. Therefore, you have a tension. But again, this tension is without subscript. Why? Because now these 2 objects, they are being joined by the same string. So there's no such thing called T1, T2 or TP, TQ. Okay, you have only one tension. So object Q. Okay, object Q, this is a free body diagram. Again, object Q is an object, therefore it's come with weight. And then it is being hung by a string, you have a tension. So the main difference between these 2 objects is one acceleration is going up and the other one is going down. Okay, so for object P, we are going to take downward as a positive direction, upwards as a negative direction. Whereas for object Q, upwards is a positive direction, downwards is a negative direction. Okay, so this question involves only vertical component, therefore you don't have to calculate fx. So summations fy is now equals to mpa. Since my a is going down, I'm going to take w as a positive vector, therefore I have wp minus t equals to mpa. So this is the first equations coming from object P. And then object Q summations Fy equals to MQA. Okay, so what do I have? I have a WQ minus T equals to, sorry, not W. It should be T minus WQ. Okay, because now I'm taking upwards as a positive direction. Therefore, my T is a positive value. So T minus WQ equals to MQA. So this is a second equation. So again, these questions, you can solve it by using simultaneous equations because they have same T and then they have same A. So how do I know they have same A? Because they are being joined by the same string and therefore both of them, they must move with the same acceleration. All right. So this is how you simplify the equation. You try to identify the similar variables in above equations and then try to think, how are you going to connect these 2 equations together? Right? You will see, you will have a better picture, better idea when it comes to problem solving questions that we're going to discuss next week. All right? So far, any questions regarding the questions 1 until questions 10? So we have... So we have seen 10 different possibility, 10 different types of free body diagrams today. So the questions involve leave, I will keep it for tomorrow. I'll leave it for tomorrow. Okay, so far any questions? No questions? Too simple?
So far, okay, madam.
Okay, so a Saplogenis free body diagram. Make sure you know all 10 of them. Make sure you know how to form equation based on the diagrams given. So tomorrow we'll look at leaf, and then tomorrow we'll be doing practical. Okay, the 2 hours for tomorrow is actually for practical class. Okay, but I will spend maybe 10 minutes to finish last 3 questions. All right, so that's all for today. You may leave the class now.
Thank you.